And all of you can thank the French mathematician René Descartes for inventing this stuff. He is the first one that mixed geometry with the coordinate plane. If it wasn't up to him, we wouldn't be here today. And he is the famous mathematician that says, the philosopher that says, je pense alors j'existe, which means, translated, I think, therefore I exist. Right? Well, the actual translation is I exist. In French, you say je pense, which means I think, alors j'existe. What he wanted to say is, we are, first and foremost, intellectual what? We hope so. Is that right, Carly? Okay. Shall we erase this whole thing now? Yeah, of course. Okay. Okay. We talked about numbers. We talked about the Pythagorean what? What are we going to talk about right now?
Area.
Area. Well, what is the area anyway? What's the area of a two-dimensional figure? Is that the outside or is that the inside or what is this? The surface. No. You're fine. You're good. The surface. I think that's acceptable. But I think I want you to be a little bit more detailed.
More specific.
More specific. What do you mean exactly by the surface, for example?
The area.
For example, this is a two-dimensional figure. That's a flat figure, right? What's the area?
Area.
It is?
Inside is 4.
Uh-huh. Inside. And that's also very true. Very true. Roughly speaking, now, remember in mathematics, we accept many definitions, but we strive for a definition that is always what? Perfect, precise. But what you said is true. The area, we can think of it as the space that a two-dimensional figure occupies, right, on the inside. Just like the volume is the space occupied by three-dimensional what? Figure. What are the classical examples that they ask you? And you can always see it on finals, on preparations, on entrance exam. Some kind of a variation between the length and the width of a rectangle, and then they ask you to find both of them given the area, right? Well, let's see how we tackle this kind of problem. Pay attention to something. Also here, you need to be an efficient what? Translator. There is no way you're going to do mathematics. First, we speak math. Second, we live math. Third, we do math. It's not the other way around. You have to speak that language, the reciprocal. I don't know what the reciprocal means. No, you're not going to solve the problem, right? Simple. Let's see how many of you can translate this problem. Example number 3. I want you to put next to example number 3, kind of very important. Okay? The length of a rectangle. What is the first thing you should do here? Draw what? Draw a picture of a watermelon, right? Draw a picture of a what? Rectangle. Let me ask you a question. For a rectangle, which one is the greatest measurement? The length or the width? Huh? We really don't care. Pay attention. Think of the rectangle as a ruler, right? You can position the rectangle this way, or you can position it which way. Customary speaking, we refer to the length as greater than the what?
The width.
But I don't want you to think that this is set in stone, right? But it's okay. The length is 2 inches more than the what? Width. That's what he said. I'm going to write down what he said. The length is what? The length is what?
2 inches more.
2 inches more than the what? More than the what? That's what he said. Okay? Then he said the area is 50 what? The area is 50 what? Inches what? Square. Remember, area is always square unit, right? Okay, so what he's saying, find the length and the what? Width. Let's remember a strategy from word problems that we talked about earlier in chapter 3 and at the beginning of the semester. When we are faced with two quantities, like length and width, what do we choose as the variable? Do we choose the length or the width? Do we choose the smaller or the greater?
The smallest.
The smaller. And how is that beneficial to us? Because I'm hoping to express the length as a function of the what? Width. So I won't be looking for two variables. Let us say, to choose the variable, I want to choose this one as x. But based on this statement, if the width is x, what should the length be?
X plus 2.
X plus what?
2.
Okay. Now let's talk. I want to see who remembers this from the very beginning. What do I do with this x plus 2? What do I do with it? Put it in what?
An equation.
In what?
An equation?
Yes. In what? In parentheses.
Correct.
Why is that in parentheses? Because I want to treat it as one factor, right? One term. Now, pay attention. You have done a lot. You have helped yourself a lot. You are damn good if you reach this point. Why? You chose the variable very efficiently as a smaller what? Quantity. You have expressed the larger quantity as a function of the smaller what? Quantity. Pay attention to what you have done, which is impressive. We were looking for the width and the what? Now we are looking for only what?
Width.
X. If I know x, then I know the width and I know also the what? The length. Okay, how am I going to set up my equation? He tells you that the area is equal to 50 what? Inches squared. But what is the area of a rectangle? It is length times what? Width. So, it is fair to say x times x plus 2 equal to what? Equal to what? 50. This is my v, how I chose my variable. And that is my e, how I set up my what? My equation, right? Then what's left? Solve. Go ahead, write it down. And I'm going to show you that solving is actually not the part that is most challenging. You want to remember that when you choose the variable, you choose the smaller variable, right? The smaller quantity, and try to express the larger quantity as a function of the smaller what? Quantity. You want to try to reduce the amount of variables that you need to find in a problem. Instead of trying to find two things, the length and the width, now I have reduced the problem to find only what? To find only what?
One. Verb.
Okay? Now, let's you and I talk about solving right now. So what was the equation that I came up with? X times what? Equal to what?
50.
50. Let's go ahead and multiply, right? Then this will be x what?
X squared.
Plus 2 what?
X.
Equal to what?
50.
50. Now what am I going to do if I were to solve this by factoring?
Move it to the
What are you
left.
going to do, right? Bring that 50 where?
Left.
To the left. So that will be x squared plus what?
2x.
Minus what?
50.
Equal to what?
0.
0. So, I need a product that is negative 50 and a sum that is what? Can we find those numbers? I think it's pretty difficult, right? Because negative 50 means negative 5 and 10, which does not give you 2. Also means negative 25 and 2, which also still does not give you what? 2. So, by factoring, it's not working. So what am I going to do if it doesn't work by factoring? For my 0306 student, I need to try either to complete the square or to do what? By group, never works. Complete the square or do what? Quadratic what? Yeah. I mean, the problem is when you say by grouping, if you're trying to find those two numbers to break down the middle term, you're still going to find it pretty impossible. So either I have to try to complete the square or I have to try the quadratic what? The quadratic formula works all the time. Of course, roughly speaking. Sometimes the radicand is negative in the quadratic formula, it doesn't work. Now let's talk. Which one do you want me to show you, the quadratic formula or complete the square?
Complete the square.
Sure, why not? They are the same. All right. So let's talk. We have x squared plus 2x, but if I wanted to complete the square, I shouldn't have taken 50 to the other side, right? I should have left that 50 on the right part side. Okay, let's leave that 50 on the right side. And what I'm going to do here, I'm going to leave some a little bit of a box here, and to see what am I going to add. Let's pay attention here. From x squared, we can extract what?
X.
X. And from that plus, it's always in the middle, right? What am I going to do here? What's the number that I'm going to choose to complete that square?
1.
Remember, you write 1, but 1 what? Actually, 1 square, which is 1, right? But it's kind of important for you to write positive 1 what? Square. It happens here that this is 1, right? All of that is square equal to what? Remember, you can't do something to the left side without actually doing the same thing to the what? To the right side. So I must also include here positive 1 what? Square, which turns out to be 50 what? Yes, sir.
Why did okay, where did 2x go?
Say that again, please, one more
2x
time.
in the middle from the top, where did that go?
This one?
Yeah.
It didn't go anywhere. You see how we said from here we extracted x, and from here we extracted 1? But remember, that was squared. So that was x plus 1 times what? X plus 1. When you multiply x and x, you got back x what? Squared. So what happened to that 2x? Continue multiplying. What is x times 1? Plus 1 what? And what is 1 times x? Plus 1 what?
X.
And what is 1 times 1? Plus 1 what? Squared. So you see you already captured x squared, right? You captured 1 squared. And then what is 1x and 1x, which is 2 what? Because we know that the middle is going to be double, right? Does that answer your question?
Yeah, thank you.
Absolutely.
So you're always gonna do like half of the,
We always do this. Half, and then raise the result to the second what? Power. All the time. Pick this number. You talk about half, which is 1, right? Half, and then raise the result to the second what? Raise the result to the second what? To the second power. Okay, now let's pay attention. Now remember, completing the square sounds easy, right? But when you try it, you find out there's a lot of little details that you still have to remember, right? That's why it's kind of confusing a little bit. Okay, let's pay attention. I kind of accomplished what I wanted to accomplish because now the left side is a perfect what? Square. Then I have to apply square root on both sides, right? For those of you who are 305, I mean, you can console yourself in the benefit that this is something you're going to see next year, or in the summer if you take it that far. Okay? Now let's pay attention. What is the square root of x plus 1 squared? Absolute what? She remembers because in the previous class, somebody forgot absolute value. They almost called 911. I had a heart. They showed medical. Absolute value of x plus 1 equal to what? Square root of what? I don't believe that we can simplify square root of 51, right? I don't think so. So now what happened now? Turns out that x plus 1 equal to square root of 51. And x plus 1 equal to what? Negative square root of 51. Anybody has a calculator? Give me an approximation of what square root of 51 equal to. What is the square root of 51 equal to? 7 what? 7 is between 7 and 8, 7 point something, right? Huh? I mean, it doesn't. Let's say approximately it is 7. Okay, it's not important here.
7.14.
0.14. Let's say 7. Approximately what? 7. It's not going to change a lot in the scheme of things here. Okay. So let us say x plus 1 is 7. So x will be 7 minus 1, which is 6. Approximately, right? Approximately. Approximately. And then here, negative 7. So x will be negative 1, negative 7, which is negative what? 8. Tell me which value you should not accept. You should reject that value. Which one?
The negative one.
Can we have distance that's negative?
No.
Can't. This value should be rejected, right? And then it turns out that the width was 6 and the length was x plus what? And I'm not sure, I forgot the problem. X plus what?
2.
Plus 2. And actually, if you think of it, or about it, this is 6 times 6 plus 2, right? Which is 6 times what? What's 6 plus 2?
8.
Huh?
8.
Which is? 40 what?
8.
Yeah, it's almost 51. What's the big deal? Yes.
If we did it the other way with the
Quadratic formula?
would it be, would it be
Same
better?
thing.
Same thing?
Absolutely same thing. I can show you. Same thing. No problem. Write it down so I can show you the quadratic formula. We derive the quadratic formula from completing the square. Both lead to the same result. But remember, for you to apply the quadratic formula, you have to have the right side equal to what?
0.
0, right? The requirement to apply the quadratic formula are the same requirement for factoring. The right side must be what? 0. Maybe it's not a bad idea to show it actually. As soon as you're already done, I'll show that quadratic formula. Okay? Shall I erase all this now? That's okay. Also, if you go to the Henry Ford, remember, if you go to Google, just type Henry Ford Community College Math Lab. They have a pretty extensive website that has a lot of useful handouts, starting from beginning algebra, adding numbers, subtracting numbers, basic operation to a little bit advanced algebraic structures. So it's very helpful. They have handout for general math, I think beginning, intermediate, college algebra. It's very useful, very useful.
Can you repeat that link?
Yeah, I'll write it down. Henry Ford Community College Math Lab. And if you send me an email, I will send you the URL anyway. Universal Registry link, right? Okay. Now, let me show you a little bit. This is the same thing if we did the quadratic formula. What was the actual equation? Now that we're talking about this. It was x times x plus 2 equal to what? Equal to what?
50.
50, right? Go ahead and multiply. X times x is what?
X squared.
And then this is what?
2x.
And equal to what?
50.
50. But for you to apply the quadratic formula, you must take that 50 where?
To the left.
To the left, right? So, transpose 50 to the left. You have x squared plus 2x minus 50 equal to what?
0.
0. Now I have to apply the quadratic what? Formula. Today in a Saturday class, I don't know what happened. Probably that Ecuadorian coffee that I drink. I showed the proof for the quadratic formula. I showed how you get the quadratic formula using a completing the what? Square. And some of the students, maybe we don't talk about that again. What is A equal to? A is what?
1.
And what is B?
2.
And what is C?
Negative 50.
Negative what?
50.
Pay attention. Pay attention. If you make a mistake using the quadratic formula, you did that because of one or two reasons. Either you misidentify A or B or what,
C.
or you are in a hurry, you didn't do the substitution the right way. Or you got creative and I don't know what you did. Hopefully, let's not talk about the third one. 'Cause, later, I'll tell you what somebody did. Let's pay attention. What is the quadratic formula? Long line. Negative b plus minus square root of b squared minus 4ac divided by what? 2a. Now pay attention. This is what I'm going to do. Look. Negative plus minus. I know all of you are not slow like me. You are fast. You don't need parentheses, but I want you to use what?
Parentheses.
That's right. But I don't need parentheses. I can do it, but you're still going to get a 0. Use what?
Parentheses.
I know. Trust me, you do. You do want to avoid silly mistakes here, right? Pay attention. All you have to do right now is what? Do the correct substitution. What is B? What am I going to put here? 2, right?
2.
Also here, what am I going to put?
2.
And what is A?
1.
And what is C?
Negative 50.
Negative 50, right? Okay? And what is A again?
1.
1. You see it's the same thing, right? Okay, let's try to do some calculation. What happened now? When I do calculation, what happened? What happened? This will be negative what?
2.
Plus minus, square root. Please don't be in a hurry thinking that you're going to impress me and then get a 0. That doesn't impress me. Okay? Pay attention. What is 2 squared?
4.
4. Negative times negative is what?
Positive.
Positive. 4 times 1 is 4, right? Times 50 is what?
200.
200. So 4 plus 200.
No.
Divided by what? 2.
Oh.
So, that will be what? Negative 2? Maybe we can write over here, right? Negative 2 plus minus square root of what? 2 or what? Divided by what?
2.
2. Pay attention. Square root of 2 or 4. I can simplify using 4 and what? Remember, 20 divided by 4 is 5, right?
51.
And 4 divided by 4 is what? 1. You see how we simplify? Well, what is the square root of 4 is what? 2. So that's negative 2 plus minus 2 square root of 51 divided by what? 2, right? So now what's going to happen? You see, I can simplify 2, right? So, or I can just repartition negative 2 divided by 2 plus minus 2 square root of 51 divided by 2. Cancel out everything. That will be what? Negative 1 plus minus square root of 51 by itself. Which is what we got the first time, right? Okay? Does anybody have any question about how we went about this? Remember, what do I say about a shy student? Don't be shy, right? That's right. It's not a good idea. It's a pretty ridiculous idea for a college student to say I'm shy. I have to be shy. Right? Was the tuition free?
Sure.
It was? Apparently, you cheated the system, didn't you? All right.
If we got the 0 in place of 2 square root 51, so we're on is going to be minus 1.
Say that again one more time, please.
If we got 0 in place of 2 square root of 51, so we're
We have impossible. You see what I'm saying, right? If this was 0 to begin with, this means your answer is negative.
yes.
You can't, impossible.
If that answer is positive,
Then that's fine. You have that answer.
So we have just one answer.
Yeah, but in math, we say it's repeated 2 times. Why? Let me give you an example. Imagine you have something like this. Maybe, let's talk about this. X plus 1 squared equals to 0. So you see, you only have one answer here, which is negative what? 1. But this is repeated 2 times. Well, how do I know it's repeated? Because we are multiplying x plus 1 how many times? 2. In other words, we're saying this is x plus 1 times also x plus what? 1. You see this plus here? That gives you negative 1 as a result, right? Also, this factor gives you another negative what? 1. This we say repeated. Now, later in college algebra, you talk about something called multiplicity of the solution or of the root, which means how many times does that solution repeat itself. And you'll see it relates very, very closely to how the graph of the function behaves. For example, it turns out if the multiplicity is even, it's tangent to the x-axis. If it's odd, it's going to cross the x-axis, which is why we always want to say repeated, remember. This is beyond the scope of this course, but it's good to know it for what's coming. Okay? Next week, I should be available on Monday and Wednesday for help. Because Monday we don't have meeting, thank God, for the NFO. So if you are available after 12, come and ask for help, or Wednesday after 12, that's also excellent. Even Tuesday, Thursday, if you let me know one day before, I'm willing to try to stay until 2 in the afternoon, or 2 to 3 or something like that. But I need to know one day before, okay? Shall we erase all this now? Yes, maybe, no? So far, what are the type of problems we talked about, Carly? I mean all of you, but I just know her name.
Numbers.
Numbers and what? Areas and what? And then what else? What else did we talk about? About what? That's right. Excellent. Turn to the example, turn to the page 5, I believe, right? Page what? Page what? Page what? 5. Okay, I want you to try to set up number 7 on your own. If you set it up and solve it, you're good. But all I want you to do is set up number what? I want to set up number what? Number what? 7. Let's take a 1 minute, try to set up number 7. After that, I'm going to show you an example from physics. When you throw an object, right? And you'll see also that relates to what? Factoring. Hopefully we'll spend about half an hour on that example. And
That's it, half an hour.
Carly, now deep down, you know you want to stay here until midnight, don't you?
Yes,
I
sure.
know. You can't. You don't have to convince me. I know. You just can't. You feel guilty when you leave a math classroom, don't you? Isn't that right, Miss McClendon? Don't you feel guilty when you leave a class? Maybe you don't feel good. How did you set it up? May I see? Yeah, that's correct. But you don't need that square, right? Remember, it's just area, unit square. So you see, Margarito set it up like this. That this is x, and this is x plus what?
3.
And the area is what? Area is what?
30.
Where's the shift? Where's the problem? 36 meters squared. Remember, this square is for the unit. It's not for the number. The square is for the what? For the unit. Pay attention. You know where the square comes from, right? It means if I partition the space inside, I can fill it with 36 what of those meters squares, right? So I know that area is length times what? Width. which means x times x plus 3 equal to what? 36, right? Pay attention. This is why it's not a good idea to do multiple choice questions. Why? In a multiple choice setting, what do? They give you this equation, and then they give you A, B, C, and what? D, right? And then all you have to do is see which one works, right? And then actually it won't, that's why you're laughing, because you know the problem will be reduced from thinking and solving to actually guessing the right what? Answer, which is, I mean, I guess it's good if you want to pass an exam, and that is the purpose of your life, but it's not good if you want to learn the critical thinking skills, right? Of course, here we have to multiply, and then we can do by the completing the square or by taking 36 to the left side. I don't think you want me to bother you with this right now, right? You just want to keep this as what? As homework, right? Because you have nothing to do on Sunday, do you? Oh, how many of you do you want me to show you the solution for? What do you want me to do? Use completing the square or use the quadratic formula?
Use the square.
X squared plus what?
3x.
Equal to what?
36.
So what happened now? If I need to use completing the square, then this will be x squared plus 3 what? Oh shit. Who said completing the square? Maybe it's better. Let's do completing the square. What can we do? It's okay. It's fractions, I mean, but so we don't have to call 911 every time we see a fraction, right? That's okay. What are you going to add over here to complete the square? What are you going to add over here?
1.5 squared.
3 over what? 2. Well, 3 over 2, and then what? Also here you're going to have to add 3 over 2, and then what? Remember, from here we can extract what?
X.
And from here we can extract the positive. And from here we can extract what? 3/2. All of it what? All of it what? Square, right? Remember, how do we obtain that number? We divide by 2 and then we raise to the second what? Oh, equal.
Where is the 3 over 2 coming from?
After. In 0305, we don't worry about that.
Okay.
0306, if you want after class, you and I can spend some time and
No,
and
thank
talk
you.
about that. Okay? 36 plus what is this? 9 over what? 9 over what?
4.
4. But you need a common denominator to be 4. That's fine. Let's put 4 here and let's multiply here by what? By 4. So what happened now? X plus 3/2 squared, right? Equal to what? What is 4 times 36 is what?
144.
Is it? Well, 4 times 6 is 24, right? And then 4 times 3 is 12, right? 12 and 2 is what? 144 over 4 plus what? 9 over 4. This means x plus 3/2 squared equal to, what is 144 plus 9? 150 what? Over 4, right? So now what happened? I need to apply the square root to both sides, right? Okay. So now what? Pay attention to something. Now you have x plus 3/2 equal to what? Square root of 153 divided by 2. Somebody explain to me where this 2 came from. Where this 2 came from?
4.
Because the square root of 4 is what? Or, of course, x plus 3/2 equal negative square root of 53 over 2. Somebody give me an approximation of square root of 153. What is the square root of 153? What is the square root of 153? Approximately how much? 12? Is that true?
12.36.
12.36? Let's say it is about 12, okay? All right, let's say this is 12, okay? Approximately speaking. This will be 12 over what?
2.
Which, well, 12 over 2 minus 3 over 2, right? But this, 6 minus 3 over 2. This will be negative 6 minus. We cannot accept this because this is going to turn out to be negative, right? So probably my answer will be 12 over 2 minus 3. What is 12 minus 3 anyway? 12 minus 3 is what?
9.
9 over 2, which is what? 4 point what?
Something.
5, right? And if you want to add that up, maybe let's say 4.8 for approximation, right? Let me see. Which problem did we do here? Problem what?
7. Where the length and the width?
Yeah, problem 7, right? Yeah, his answer was 4.68. But of course, this is also a pretty good estimation of what we're doing, right? That's just fine, no problem. All we are doing here is we are estimating, right? Also here, we must reject it because that is a negative what? That is a negative what? We can't have that. We can't have a distance that's negative, right? Nobody's going to say the length of my house is negative 6 feet. It doesn't. It's a pretty ridiculous statement, right? All right. I know you're tired, but I know you feel good now, don't you? We talked about area problems, Pythagorean theorem problem, finding number problems. And what else did we talk about? Maybe physics, right? Let's talk about physics. Let's talk about what? Physics. How many of you took physics in high school? Huh? Somebody, even if you didn't, somebody lie and say you did, and just raise your hand. So I don't commit suicide or something.
I
You
did.
took physics, Carly? What is gravity, Carly?
I don't know.
Alkass. What is gravity? The force that does what?
It's the force that one body attracts another one. Kind of.
I think gravity is the reason all of we, as planets, we revolve around the sun, right? Because the gravitational pull to the sun, right? Gravity is centered down, right? No?
Kind of.
I think all of you should close your Facebook account, start watching PBS Nova and all those science.
Do we need that?
Huh?
Do we need that? No more battery.
Oh, that's okay, no problem.
Yeah.
Let me just run quickly over one physics problem, just showing you the setup, and then I'll let you go, and then so you can talk to all your fake friends on Twitter. They missed you. Just hopefully you don't end up doing like that football player. What's his name? The one that says he started crying about his girlfriend dying, and turned out that she's still alive, and she's not even his girlfriend. Oh, disturbing. Like, what kind of mental? I don't know. He's
an actor.
It was very disturbing. And then the more he tried to explain, the stupider he sounded. Oh. Let's talk about number what? Number what? Let's talk about number what? Number what? 12, number 5, example 5. Somebody read to me example 5. That's the last example we're going to do. We're going to set it up, and then we're going to let you go. Let's talk about example 5. What is example 5? Somebody read for me example 5. What's the name of the lady?
Sam.
That's a Middle Eastern name, don't you know that? It means forgiveness. Samah. Trust me, I'm not forgiven, but just the name means forgiveness. Samah throws a ball vertically, right? Into the air with her mighty arm. Whenever they do this, you know the problem gonna be stupid. Anyway, by the physics formula, st equal to what? Negative 16 t squared. You know why negative 16, right? Because we are doing against gravity, right? It's kind of ascending instead of what? Descending. And remember, mostly in physics, negative and positive are in reference to the vector direction, right? To the vector direction. For example, if you're driving, we say your speed, which is the magnitude of your velocity. For example, we say your speed is 60 miles per hour. But when we talk about velocity, you need to tell me the direction. In what direction? Is it positive 60 miles per hour or negative 60 miles? What do you mean by negative? For example, imagine you're going from here to your house, right? And from your house to here. Well, if you drive at 60 miles per hour, the only difference here is the direction, right? Then how do we know? We have to assign one of them to be positive and one of them to be what? Negative. That's the only way we can make sense of velocity versus speed. Your speed doesn't change. Your